Pearson's coefficient of correlation. Again, we have to find out what is the relation between the two things. So now the requirement for the Karl Pearson's coefficient of correlation is like we don't require the ranks data. We require the actual ordinal or the rank scale data in the form of your inputs. So in the Spearman rank correlation, we want the data in the ranks, but in the case of like Karl Pearson's coefficient of correlation, we need the data in the ordinal or the you can say. So we can go, if we are given with the data like ordinal or rank, we can find Spearman rank correlation by converting the data first into ranks. So first we can convert the data into ranks and then we can calculate the Spearman's rank correlation. But if we are provided with the data with the ranks, then we cannot find out with the Karl Pearson's coefficient of correlation, because from ranks we cannot come to the ordinal or the ratio data. But from the ordinal and ratio data we can come to the rank data, because we can say that this is the first rank, this is the second rank. But if we are having like first rank, second rank, we cannot say that if the person has scored 10 marks or 12 marks or 13 marks. So that is the like, so criteria for Karl Pearson's coefficient of correlation is you must have the data in the form of either ordinal or the ratio scale. Clear? So let's take the example. So these are the X and Y. Let's suppose X will be the maybe expenditure in thousands, and Y may be the sales in the thousands. So they are the two variables given to you. One is maybe expenditure and one is the sales. And now you have to find what is the relation between this expenditure and sales. Clear? So you want to find what is the relation between the expenditure and sales. If it is like if sales increases, expenditure also increase, or if expenditure increase, sales will also increase, or whatever. So we want to find what is the relation between the expenditure and sales. So we have to take the example. So let's suppose we have the expenditure of 100 products and we have made so we want to make this like so this is the data for expenditure for 10, and this is the expenditure sales data for these 10. Now we want to find the correlation between the two. So the Karl Pearson's coefficient of correlation, the formula will be like n summation xy. So we will write the formula for this. So it will be like n, then summation of xy. So n summation xy minus of summation x into summation y. Fine. So n summation xy minus summation x summation y whole divided by n summation x square divided by n summation x square minus summation x का whole square. minus summation x का whole square and इसका under root also and the under root of this. And multiply by similarly n summation y square. So this is your one term and then next term will be your like I'm explaining you again also I'm writing the formula in notebook also to show you more clarity. And then n summation y square minus n summation y whole square का under the root. So that will be the formula for like karl Pearson's coefficient of correlation. So if I'll represent this in a copy also, so the formula will be like so the formula is R is equal to n summation xy minus summation x summation y whole divided by n summation x square minus summation x whole square का under the root and n summation y square minus summation y whole square का under the root. So that is the formula for like karl Pearson's coefficient of correlation. So which will present here I like n summation xy minus summation x into summation y whole divided by n summation x square minus summation x का whole square का under the root and n summation y square minus summation y whole square the under the root. So that is the formula for like karl Pearson's coefficient of correlation. Clear? So now we have to find each and everything step by step and put in the formula to calculate the value of R. So first R the requirement is N. So N here is 10. So the value number of values in this is 10. So N value is 10. Now next thing is you want like summation xy. So for that you have to multiply first x and y. So if you multiply this x and y, so this comes out to be 400 and then we'll drag the same as we are working on Excel. So we'll come out with the values of xy. So then the summation of xy, so it will make the sum of this. So it become like, so 1865 will be the sum of summation xy. So n and summation xy we got. Then the next thing we want summation of x. So this is your x. So make the sum of this. So this will be your summation of x. Sum of y. This will be your summation of y. So numerator you got n you want n you already got summation xy minus summation x and summation y. Then in the denominator you have n into summation x square. So first you want the x square values. So you have to make the calculations for x square which will be equal to x multiply by x itself. So this becomes your x square values. So this is your x squares. Now you have to make this summation of x square. So this is your first part in the formula like summation of x square. ठीक summation x square you got. Then you want summation of x का whole square which you have already calculated at summation of x. So you have to square this. Now next is summation y square. So for that you want to calculate y squares. So y square will be like is equal to this is your y and again multiply by y. So this will be your y square values. We'll drag it. So it will be like y squares and then the summation of y square you will get like. So all the values you'll get now. Apply in the formula and calculate the karl Pearson's coefficient of correlation. So which will be equal to, we will be calculating numerator and denominator separately. So the numerator becomes is equal to n. N is your 10 multiply by summation xy. So summation xy value lies in this cell. Then minus of summation x into summation y. So which will be equal to summation x is 134 and into summation y is, so this becomes your numerator n into summation xy minus summation x into summation y. So 1364 becomes your numerator. Then we'll calculate the denominator. So denominator will be again n. So which will be equal to n multiply by summation x square. Summation x square will be this 2080 minus of summation x ka whole square and complete ka under the root. Complete raised to the power 0.5. So this will be our first part, which is saying like n into summation x square minus summation x ka whole square under the root. And similarly, another part will be like and multiply by or do it in the another cell. So this is your first part. Second part similarly says which will be equal to n. Again, n is your 10. Now summation y square. So summation y square is this minus of summation y whole square. So this is your summation y whole square and complete under the root. So this becomes your second part of the denominator. Now the answer becomes, the final answer becomes is equal to numerator divided by this multiply by this part. So 0.55238, that becomes your Karl-Pearson coefficient of correlation. So the Karl-Pearson coefficient of correlation for this data comes out to be 0.5524. So which means that it is a positive correlation, but it is a weak correlation because it is only like a value 0.55. We can say a high correlation if it is like 0.75 or 0.85 or so, but 0.55 value shows that it is a moderate positive correlation. Fine. Now let's change the data. Like suppose perfect positive correlation. If all the expenditure and all the sales values are same, it is a case of perfect positive. So let's take the example. We'll change the expenditure data to sales itself. So let's change this. So after change this, so we get like the correlation coefficient is 1. The R will be like, so this becomes the model for correlation coefficient. So after changing the logically also it should be perfect positive correlation because everything is like same, a high perfect positive correlation. So logically also should be +1 and also the answer comes out to be R for +1 only. So that is like the model for like Karl-Pearson's coefficient of correlation. Fine. Now, if we want to do it with the shortcut method, so here we are doing the things on the Excel. So we can have any calculation on the computer very easily. But because you have to do it on the manual side, so if you have to do it on the manual, maybe this number is not 2000, this number is 2022. This is 2025, this is 2023, and so on. So now multiplication of these, this will becomes very complex. So this becomes very complex if you have to do the things on the manual side. Doing on the Excel is not having any issue, but doing on the like the manual thing, it will be a problem for you. So for that, we have availability of the shortcut method, as in the case of like central tendency or dispersion we have done. So the again the shortcut method says assumed mean method and the step deviation method. So in this we are stopping up to the step assumed mean only. We are not using the step deviation in this case because there are two variables involved. So avoid confusion to that. So but we can do the questions to simplify our calculations using the assumed mean method. So what is the assumed mean method? So here like suppose we'll take the again the data. So if suppose this is the data we are taken again, we'll change the data accordingly. So this is the data suppose again, and now these values are not two figures. It will be like 2000, 2050, or 2100, 2150, 2200, 2250, 2300, then 2350 and 2400. And 2450. Suppose this will be your first data set, and the next one will be your like maybe uh, This will be the data now. Now you want to calculate the Karl Pearson's coefficient of correlation. So again, if you have to do with the direct method, so you can do it on the Excel because there is you have to simply drag it and calculation has to be seen by Excel itself. But if in case we want to do it manually, it is very difficult to calculate the calculations for these big numbers. So what we can do, we can make it at assumed mean at dx. So dx will be equal to x minus a, which is your m value, which we have already done. So assumed mean like the minimum and maximum divided by 2. So if we are doing it like so minimum is 2000, maximum is like 2450. When you do it like divided by 2, it comes out to be 22225. You have to see the value nearest to this data. Let's suppose 2250. So you have to subtract each and every value from 2250. So that will be like this minus 2250. So this will be your dx values. One second. So this will be your dx values. Now again, you have to apply the same thing for all the data. So this becomes your dx values. Now the similarly, you can calculate the values of dy. So dy will be equal to, again, you have to check the middle value. So which will be equal to 65 is the minimum value in the data. Maximum is 7400 and again divided by 2. So 6950. So the nearest value to this 6950, either you can take 69 or you can take 7000, whatever. So here we have taken 2250 as our assumed mean. Here we can take our mean as assumed mean as 6900. So for y, we can take 6900 is our assumed mean. So which will be equal to y minus a. So dy is equal to y minus a y. So which will be equal to, so this is your y is individually minus, this is your assumed mean. So this is your dy as values. You drag it, and now making the calculations with this is much easier as compared to 2000 and 6500. So whatever the formula is, just replace, like here the formula is, so just replace where there is xy, the x becomes dx, y becomes dy. So that is the only difference in the like formula. So formula signify like n summation dx dy minus summation dx summation dy divided by n summation dx square minus summation dx whole square under the root, and n summation dy square minus summation dy whole square under the root. So wherever there is x is replaced with dx, where there is y it is replaced with dy. So that is your assumed mean method and the shortcut method. Again, you don't have to like plus a in the data because here again two terms, one is plus, one is minus, so that a square and a square get cancelled out to each other. So in the assumed mean, there is no need to add back the data back. So that is your assumed mean method to calculate the Karl Pearson's coefficient of correlation. And the important is the interpretation of the same. Interpretation is important as you have done with this. Suppose this is the data. Now if I make, because I have actually made the data model for this, so let's change the data here, because now we have to replace x with dx and y with dy. So let's suppose do this here because we have already applied the formula here. So if we do it here like this, so the Karl Pearson's coefficient of correlation again comes out to be 1. Why it is 1? Because each and every value of this is also increasing and this is also increasing. There is no deviation in data, like every value in this is also on the increasing side. Every value of this y is also on the increasing side. So that's why the again the Karl Pearson's coefficient of correlation comes out to be plus 1. So let's take if it is 50. Let's suppose then the Karl Pearson's of coefficient is not plus 1, it is 0.987. So because of this value, because it's this all is in the increasing, but this value is in the decreasing mode, one value. Because of that, this is not perfect positive, it is minus 0.987, which shows that it is a high positive correlation, but not a perfect positive correlation. But if we are the data is moving in the opposite direction, so automatically this R value comes out to be like minus zero point 0.6 or minus zero point 0.7 or so, signifying that it is a negative correlation between the two variables. If one will increase, the other will decrease. So that will be the symbol for, and that will be the representation of your negative coefficient of correlation. So you have to check that whether our coefficient of correlation is positive or negative, and accordingly you have to interpret your results in that. Because interpretation of the results is more important, because otherwise you can calculate using Excel or something like tools like this. But once So interpretation is important, because the interpretation is like, because you can calculate it through using Excel the calculations, or today's time we have in your research, maybe your practical research in the future, you need not to calculate the things manually. You have the softwares available like SPSS or Excel or R square the models are there, like you have the inbuilt functions available, you can use that. But ultimately they will give the answer like 0.987. So the models or SPSS or something, whatever it is, they give the like numbers. But ultimately you have to interpret the data. What is the meaning of this 0.987? What is the meaning of 0.632 and all that? So interpretation of the results is important to understand here, like what is the meaning of this Karl Pearson's coefficient of correlation, and which value signifies which thing. So that is the like Karl Pearson's coefficient of correlation. So that finishes your correlations. Now the next thing comes after correlation, that is your regression. So I have already discussed the difference between the correlation and regression in the previous class. So that is like the correlation only tells me the like relation between the two variables, but the regression will also tell me like which is cause and which is the effect. So it will also signify that cause and effect relation between the two variables. So that will also like, that is a one step ahead of the correlation. So it will also tell like if age is because of height or height is because of age, but correlation will only tell me the relation between the age and height. So that is a difference between the like correlation and regression. So now the next thing is your regression, in which we want to analyze that which is the cause and which is the effect. So it is again a practical tool in our like maybe future research purpose also, because we have to analyze that which is the, what are the causes to a particular problem. Suppose we face with a certain problem and it has some causes. So we have to find out that which cause is impacting much that my effect. So there is n number of causes. So we want to analyze that which cause is affecting much cause or much effect to my effect variable. So it is like a dependent and independent variable. So there is may not be a single independent variable. We may have a n number of independent variables. Now we want to check which variable has impact most on my dependent variable, which is less, and accordingly. And the researcher can, or the implications of that is, the variable which is impacting the most, I have to take care of that thing with the priority. For example, I want to know the satisfaction level of the customers. So the satisfaction level of customer will be my dependent variable, but it may depend upon like the service quality or maybe product quality, location, ambience, A, B, C, D, E, F. 10 factors are there. But the all 10 factors are not equally impacting my satisfaction. So I have to see that which variable is impacting the satisfaction the most. So that is done through regression. I want to see the which has more effect. So that can be done through the cause and effect relation. And the one which I have found the most effective, like that variable which is impacting the most, I have to see it at a more priority. If I have a business owner of that particular concern, I have to take care of that particular factor with a great concern, that that factor should not be like diluted at any time. If food quality is the at most comes factor which impact the customer satisfaction, then I have to ensure in the like every time with the priority that my food quality should be like of the high quality itself. I cannot compromise on food quality at any time of the day or the business. So that is the application of this like regression analysis in your maybe practical research purpose or something. Fine. So that is your regression analysis. So regression analysis deals about the two things. One is it is a regression line. So we are doing here, we can manually do here only the linear regression in which we want to analyze the effect of one variable on the another. We cannot see the effect of more than one variable on the one in manual. But if we want to see the effect of like 10 variables on one variable, it can be only done through software called maybe SPSS or R or something. But manual thing we can do only for one to one independent and one dependent. But the dependent variable must always be one. Dependent cannot be more than one. Independent can be more than one, but dependent variable always is one. We have to see the effect of more than one factors in on one factor. So that is your multiple regression. So dependent is always a one, but independent can be more than one. So that is your multiple regression in which the independent variables are more than one, and simple linear regression is the one which we have like only one variable in this. Excuse me. Fine. So now the regression analysis is so the regression line. So first is the regression line of the regression. So under the regression we have the regression line. The regression line will be y is equal to a plus by x x. So this becomes the regression line of y on x. So y on x means how the x is dependent on y. Sorry, how the y is dependent on x. So it is like whichever is dependent variable is right on the other side. So how the y is dependent on x. And so this is y is equal to a plus byx x. So where x is your independent variable, y is your dependent variable, and byx is regression coefficient of y on x. Similarly, if we want to see the effect of how x is dependent on y, so the regression equation becomes x is equal to a plus bxy y. So this becomes the regression coefficient of regression line of x on y, where x becomes now dependent and y becomes independent. So these are the two independent things. In correlation, rxy or ryx are both are the same thing. If you can say rxy or ryx, so both are equal to each other. So it is not like there is any difference. If you find the correlation coefficient between age and height or height and age, it comes out to be the same because it does not have any cause and effect. But if you talk of regression, bxy is not equal to byx, because here the cause and effect will be reciprocate to each other. In one, the y is the dependent and x is the independent. In another case, x is dependent and y is the independent. So there will be like two different things, as in the case of if you consider this similarity between the permutations and combinations. So correlation is a kind of your called as a combination in which, so combination and permutation, the difference is like this only. We have to select two things. Now permutation is like arrangement of the thing. So if I am selecting 1 and 3, so 1 3 placing at 1 3 or 3 1 is the two different permutations. But selection is only one. Either you select 1 3 or 3 1 is only the one, because you have selected 1 and 3. So regression is a kind of permutation, and correlation is a kind of combination in which the R12 and 21 are the two different things in case of regression, but R B12 and B21 will be the two different things in the case of regression, but R12 or R21 is the one and the same thing. So that is the basic difference between the correlation and regression. So now we want to find with the regression analysis this regression line. So regression line we want to find. So regression line means we want to calculate this value of coefficient A and the coefficient BYX. So we want to find these two values. One second. Hello. Yeah. So for this regression analysis, we want to find these values of A and B by X. So ultimately, if we found the value of this A and B by X, so which signifies that this value of B by X will signify that how the Y is dependent on X. So let's suppose we'll take the raw example now. We'll consider later on how we can calculate it. So let's suppose y is equal to 1.2 plus 2.4 x. So this suppose becomes the regression equation after solution of the regression. So we come out with the value of a as 1.2 and byx is 2.4. So now this particular regression line will tell that how the y is dependent on x. So that is 2.4. So this 2.4 is the slope of the line, you can say. So it is a linear line, and this a is called as the intercept and byx is called as the slope. So byx is the slope of the line and a is the intercept of the line. So again, the two things have their own like implication. So if this is 2.4, so this 2.4 says it is a positive. Positive means if x increase, the y will also increase. So it is a positive effect on that. So if I'll increase this x, so y will also increase. But if we increase x with 1 unit, the y will increase by 2.4 units. So that is the like implication of this. So higher the value of like regression coefficient, that means more the impact of that independent variable on the dependent variable. So if this value will be like 7.4, so that means it will be impacting more our dependent variable. So that will be the signification of this like regression coefficient. And the intercept is like intercept. The meaning of interception, again the significance is like, suppose let's take the example of age and height. So we everybody knows that as the age increases, the height will also increase. As the person has born 0 day, 1 day, 2 day, 3 day, as the days progress, age progress, the height will also progress. So that is a well-known fact that if the age will increase, the height will automatically increase. So it has a positive correlation. So if I change this y and x, so y becomes your height because height is dependent on age. So this h becomes height is your dependent variable is your height and independent becomes your age. So let's suppose this becomes your like regression equation. Now, if you'll check out with this 1.2, so this 1.2 says it is an intercept. Intercept means if age is zero, the height is not zero. The 0 day individual has a certain height also. It is not like that if the age is zero, the height is also zero. So that if that independent variable has a zero value, it's still, if I have no food quality, let's suppose we'll take the food quality as a satisfaction measure. If there is no food quality, still there is maybe a minimum level, but there's still a satisfaction level available. So that satisfaction level at food quality is equal to zero is known as intercept. So the intercept is like if the independent variable has a zero value also, but still there is some value for the dependent variable, that value is called as intercept. Fine. So that is the like representation of this a and b y x. So ultimately we want to find these values of a and b y x if we want to find the value of y on x, and if we want to find the values of x on y, so we have to find the values of a and b x y. Once we'll form it, we can make it in the use like for forecasting also. So we can use it for forecasting, like if the sales and expenditure data is there. Now we have made one regression line on the sales and expenditure for 10 years. Now we want to find what is the, like we have made one equation. Now we want to find what is the value of sales if my expenditure is 2000. I have made one regression equation. I can simply put the expenditure as 2000 and calculate the value of sales accordingly. So that is the like case, the regression application in case of forecasting. I can make one model, and now if I can see the value of independent, I can have the value of dependent accordingly. So we can make that as use of a planning tool also. So that's why regression will also help in the planning of the things. It will help me in the making the like predictions of one on the another, how the one variable depends upon the other, and so. So that is the application of the regression analysis, and is again important in the research part, because like many of the studies will be causal research itself. Majority of the studies are like causal, that we have to discuss what are the various factors, how they are dependent on upon that independent variable and all that. So wherever it is, like we have to apply this regression analysis only. So there is like structural equation modeling is there. So SCM is there nowadays. So SCM is also showing that cause effect relation. So SCM is also like which variable is impacting the most and all that. So that SCM also apply with the regression only. So the base of the SCM also is the regression, in which we want to see that which variables is impacting which at which sense and all that. So that will be your like regression analysis. Fine. So regression, if we are drawing the graph of the same, so the graph will be like we make a line graph of this. One second. So if we make a line graph, so the two variables and we like suppose this one. So let's take this example and we can make a line chart of this or a scatter diagram for this. Fine. So this is the scatter diagram we have made. So this is your intercept. So if we see this data, so this is the intercept. That means 6500 is the intercept, and this slope will signify the like the this slope will determine if it is this sloped or a moderate slope. So it will see the one united change in x, how much unit in y is there. So it will change the one unit in x, so we can project in this way. So we can project this way and down, and one unit in x. So how much change in the y is there? So we can signify with this like slope of the line, the coefficient of byx or bxy. So if we making the graph, so obviously the practice is like dependent variable is on the y-axis and independent variable is on the x-axis. So on the first example, if we want to compare like what is the effect of age on height. So age on height we want to find. So age on height, that means height is the dependent. So the height must be the y-axis and age must be on the x-axis. But if we want to compare a vice versa, what will be the effect of height on age? So I want to find the effect of height on age. So age must be on the y-axis and height on the x-axis. So accordingly, we have to alter the graph because there is two variables involved over here, dependent and independent variables. So we have to frame out the graph accordingly by changing the axis of the graph if we want to see the effect and cause inverse relation. So if we want to make the effect as a cause or cause and effect, we have to make the inverse of the graph also to interpret the results from the graphical point of view. Fine. So, but ultimately, again, the same problem as we've compared in this scatter diagram. The slope will not determine the exact notification. Maybe for somebody it is a positive, that it is not correlation, or so that is the problem in this subjectivity. So to avoid that, we have the regression equations or regression modeling available, so which will calculate the exact number that how these two are exactly correlated, regressed to each other. Okay, so I am stopping here. So we will be discussing the data now. So I'm stopping the recording now.